Now we're going to look at resolving some absolute value inequalities. Inequalities, of course, differ from equations in that we're dealing with less than or greater than. In this case, greater than or equal to. Okay. So we're going to ask to express this, get some idea of what of an alternate way of writing this. Okay. Again, without the absolute value. So I'm going to look at a number line, okay? And on the number line, okay, I'm going to say, let's take a look at the values of, well, that should just be open circle since that 5 is not included. So we'll just start that again, okay? So here we go. Here's a number line. Nope, sorry. Number line's coming any minute. Now, here we go. Here's a number line, okay? Now, we suspect that 5 and -5 might have something to do with it, right? Well, take a number, okay? What number can go into here and make that true? You know, well, certainly you can put in, you should certainly put in 4, 3, 2, 1, okay? 3, the absolute value of 3 is 3, it's less than 5, okay? What if we sample on this side of -5? Well, can we go to -6? No, because -6, the absolute value is 6, which is not less than 5, okay? So it kind of reasons that what you have here is, okay, all the numbers between 5 and -5 as the group of numbers satisfying this expression, okay? So we're not including 5 or -5, so what is that group of numbers? Well, that group of numbers, okay, is effectively the interval, okay, -5 to 5, as we talked about intervals before, but, okay, more so, what we're going to say is that this interval is, okay, the values of x that are in between 5, it's sandwiched in between 5 and -5, okay? So let's kind of generalize that before we look at this problem. So, you know, basically then, if I have an expression, absolute value of x is less than some number, let's say just any arbitrary number a, then that means, okay, it's all the values that are sandwiched in between a and the opposite of a, okay? And just for a variety, let's put the equals bar there so we fill this in, okay? So then that's what we get, okay? Which means, okay, the cost of removal of the absolute values is to rewrite this as x is less than or equal to a, and at the same time greater than or equal to the opposite of a, okay? Let's kick that up a notch and apply it to a problem. Let's say we have the expression 3x plus 2 absolute value is less than 7, okay? So now, all right, in a sense, this is the exact same thing as this, okay? Effectively, the 7 serves as the a, and the x is just the entire grouping, okay? It's this expression 3x plus 2. So 3x plus 2 is effectively the x here, which means 3x plus 2 is going to be sandwiched in between the 7 and its opposite, -7, and we did include the bars here, okay? So that means that's exactly the same as this statement. Again, and this is only going to apply in this instance when we're talking about inequalities of a less than nature, okay? So here we have, okay, the absolute value of x is less than a. It implies that whatever's in the absolute value bars is going to become sandwiched in between the value out here and its opposite. And that's what we did. And from here, we're going to simplify that. We're simply going to say, well, I need to subtract 2, but I need to subtract it out of the middle and off of both sides, okay? Which will leave me with the 3x less than or equal to, over here I guess we get 5, okay? Over here we're going to get -9. Now of course we're going to divide by the 3 in the middle and on both sides, okay? And that's going to give us 5/3 over here. And then over here, it's going to give us, of course, -3. So what we can say is the solution to this is the interval. The solution interval is all the values from -3 to 5/3 inclusive. And remember when we talked about intervals, we said if we include those, we're going to put the bar here, okay? I mean the bracket as opposed to parenthesis, okay? So let's look at another example. Only this time, let's turn that around to the greater than example, okay? So let's get a new page, and we'll look at that. A new blank document, okay? And so now we're looking at the ones of the variety, okay? Let's say we say x is, the absolute value of x is greater than 4, okay? Now from a graphical standpoint, let's take a look at that. We suspect we're looking at values in and around 4 and in and around -4, okay? Well, and again, we can say not inclusive of 4 because the bar's not there. Now, obviously, 5, 6, 7 will satisfy that. So graphically depicting the solution there would be this, okay? With the arrowheads going that direction, all right? Over here, to the right of -4, -2, -2, when put in absolute value -2 is 2. That's not going to satisfy that. It's not greater than 4. What about to the left of -4? -6. -6, absolute value is 6. It satisfies, okay? And I think won't take much to convince you, hopefully, that this set of numbers applies. Now, what is that? This unto itself is all the x values greater than 4, and this is all the x values less than -4. Yes? Okay. So we removed the absolute values and we wrote it as two inequality expressions based on the graphical depiction. So what do you think? On a general notion, the absolute value of something greater than A implies, okay, what's inside x is greater than A. I usually connect these with the word or x is less than the opposite of A. Okay, so this is kind of a definition of sorts for dealing with absolute value inequalities of a greater than. And let's take a look at a little bit more detailed example. Let's say we have something of this sort. Let's say we have, okay, 3 plus 2 times the absolute value of x minus 5, okay, is greater than or equal to, let's say, I don't know, 11, okay? Say 11, okay? Fine. All right? Now, first off, it's not quite ready to apply this. It's only ready to apply that when we isolate the absolute value. So, you know, we can certainly subtract 3 off of both sides. So we got 2 absolute value x minus 5, okay, greater than equal to 8. We're going to divide by 2 now, okay. One note of caution: had that been a -2, and we might look at this as another problem, but if that had been a -2, remember, in an inequality, dividing by a negative will reverse the sign here, So we don't have that problem here, but it's likely to occur in other instances, okay? So, but here we could just go ahead and divide by 2. We get absolute value x minus 5, okay? And that's, of course, greater than or equal to 4 now. And now, well, let's see. Now it meets this mold up here. It is very much like that, okay? Again, don't think of x in here as a single term. Just think of whatever is inside the absolute value bar as the x, okay? Now, so we can rid ourselves of the absolute value by rewriting that without the absolute value, comparing it to 4 with the same comparison, and comparing it to the opposite of 4 with the opposite comparison, okay? So that's it. So when you compare it to the number here, it's the same comparison. When you compare it to the opposite of that number, it's the opposite comparison. Here we go. We're pretty much home free here. Okay. All we're going to do here is we're going to say x is greater than or equal to 9. Okay. Over here, we're going to of course add 5. That gives us 1. So x is is less than or equal to 1. Okay. So what is that? We could of course represent that in a sense like we did up here on a number line, or we could represent that with 2 intervals. The intervals come in from let's look at this one. It's 9 on out, so it's the interval from 9 to infinity. All right, because we can never, we actually are going to bracket 9, but we can never bracket infinity. Okay, so it's that interval as well as, okay, this interval, and we'll just say, well, as well as can be expressed as the union. Okay, so that's the union, and this would be what? This would be everything less than 1. So the interval would be coming in from negative infinity up to 1. Again, you never bracket infinity. So there you have it. This absolute value inequality resolved, and the solutions expressed in interval format, which is going to be the way in which we want to express all our solutions, because unlike equations, there's not a single value. There's infinitely many values, and the way in which we can express those infinitely many values is as shown here with the interval notation. Again, solving that systematically, using that as our condition for the absolute values expressed greater than. Break it down. The cost of removing the absolute value bars is to compare it to the number outside and compare it to the opposite of that number outside with the opposite comparison. So now that's the end of that.